Hello, my name is Jackson Clifton, and this is my Physics 2212 Lab 1 charge tapes. Um, for my introduction, the point of this lab is becoming familiar with the idea of charge, a property of matter, designing experiments using household objects, making estimates, and simplifying assumptions, and access for the objects. Purpose for this experiment. In this experiment, a charge will be prepared on pieces of scotch or after observing their interactions, an experiment will be done to determine approximately how much excess charge is on one piece of charge-cleared tape. Fundamentals of my experiment. Using tape to model point charges by assuming each piece of tape has had equal distributed charge in order to apply Coulomb's law. Using Newton's second law of force equals mass times acceleration and Coulomb's law in order to calculate the charge on each piece of tape. And for Coulomb's law, it gives the electric force between 2 point charges. And as you can see, the formula is right there for the force. And obviously, K is Coulomb's constant is equal to 9.0 times 10 to the ninth Newton meter squared over Coulomb squared. And my Q1 point charge, my Q2 point charge, and R is the difference between the two charges. For my results, I found that the charged pieces of tape repulsed each other. The charged pieces of tape were found to be positively charged. The amount on each piece of tape was determined to be 1.34 times 10 to the negative 8 coulombs, and that each piece of tape was determined to be deficient of about 8.4 times 10 to the 10th electrons. My models and assumptions. My models. Each piece of charged tape was used to model a point charge in order to observe interactions between them on a macro scale. For my assumptions, I assume that air resistance is negligible, treating a long tape as though it were a point charge with all the charge concentrated at the center of the long tape, and assuming that each U-tape had about the same amount of charge evenly distributed along the length of the tape. For my experiment, my system was tape B and tape A. The surroundings were everything else in the room. My initial conditions, 2 pieces of approximately neutral tape also being about equal in length, and a third piece of neutral tape stuck down on a desk. My details, tape B was stuck to the tape on a desk and ripped off quickly in order to charge it, either leaving behind electrons or gaining more electrons through the process. The tape was then hung near several objects to determine its charge. It was finally placed above the other piece of similarly charged tape, tape A, until a portion of it floated and the distance was measured between the tape to calculate its change. And beneath all the words I've just read, you can see the figures that display the process for my experiment. Also, in my experiment, my observations, the U-tape was attracted to my hand. The U-tape was repelled by another piece. U-tape was attracted to a neutral book. U-tape was attracted to a negatively charged. Sorry, I'm stuck at typing. In conclusion, the tape was positively charged and had lost electrons in the charging process. And again, in figure 3, you can see that during my experiment, the tape was attracted to my hand. For my data and calculations, tape's mass was 0.000221 kilograms. Tape length was 0.221 meters. Tape width was 0.019 meters. The distance between pieces of tape was 0.0273 meters. And the force of gravity, force equals mass times acceleration, equals 0.000221 kilograms times 9.81 meters per second squared, equaled to be 0.00217 newtons. Charge on the tape. Acceleration of tape is 0, so forces on it must be balanced, meaning that the charge was 1.34 coulombs. Furthermore, with my data and calculations, the number of electrons lost by a piece of tape. Charge of tape divided by charge of single electron, 8.37 times 10. Sorry. The area of tape was tape length times tape's width, which was 0.00421 meters squared. Area of atom is equal to length of atom squared is equal to 1 times 10 to the negative 10th squared, which is 1 times 10 to the negative 20 meters squared. And another number of atoms on the tape is the area of the tape divided by the area of the atom, which was 4.21 times 10 to the 17th atoms. And the ratio I found was that 1 electron for every 5 times 10 to the 6th atoms. Here is my glow script model. Um, you can see the inner tape B was the sphere, while tape A is the blue sphere, and the orange arrow represents the electric force. The green arrow represents the gravitational force. As you can see, the forces on tape B are obviously this is completely accurate representation of my experiment. As you can see, my code is here. My model discrepancies: no true point charge. Charges on each tape are likely not exactly equal. This is due to outside error, since it's not a perfectly controlled environment. Like I said, unequal charges on tape have been the same for each, and some charges may have been due to my handling it. And discussion: what if electrons had positive charge and protons negative charge? What would change about the observations you made with your tapes and other charged objects? And why is it important to handle charged tapes as little as possible? But how charged tapes come in contact with your hands or other objects? And thank you for watching. I appreciate it.